Hello, 9E and 9F. This is a video for you to watch to learn about this device, which is called a Geiger counter. We're going to see how that works. In German, it's the Geiger Zähler. We're going to do a 3-minute test. We're going to understand how this thing measures radiation and the units of radiation. We're going to talk about background radiation, naturally occurring radiation, and then how to use the zero or null effect with a little tiny bit of math. Okay? That's what this is about. All right, so I'm going to move the camera down and point it at this thing so you can see it. In fact, maybe I'll tip you up. Can I do that? Let's see. Yeah, it's not ideal, but it's all right. Sorry, it's at an angle. That's tough. Okay, so here it is. If you listen, there's the amplifier, actually. If you listen, you might hear some little clicky sounds. Okay, do you hear that? Okay, well, it's pretty soft, but anyway, there's some clicks happening. Turns out this thing measures, although it's called a Geiger counter, it doesn't measure violins, it measures radiation. And we're going to do two things at once. I'm going to do a 3-minute test with you and just measure the thing. So what I'll do first is I'm going to turn it on, and you'll see whenever it clicks, the number changes, okay? And it seems kind of random, and it is sort of random. It's just picking up radiation from the outside world. Now, this is actually covered with a plastic case, so I'm going to take that off. So now there's a really, really, really thin plastic sheet, and the 3 types of radiation, alpha, beta, gamma, can go through this little sleeve and go into the Geiger counter. We're going to draw this and see what's inside. So, on your notes, I'd like you to do 2 things at once. First off, you can make a little spot for the 3-minute test. One way to describe the radiation is in clicks, okay? Or we can also say counts. So how many counts, how many numbers are there? And you can see it's going up now. I turned it on and now it's up to like 27, 28, okay? So it's gradually increasing. Turns out it's just picking up radiation that's around everywhere in the room. There's some radiation. We'll talk later about what the sources of those are. So we're going to do 2 things at once. I'm going to take my wristwatch off for a sec. We're going to use it as a timer. And we're going to start at a certain time. I'm going to do it at 2:45. And ready. Okay, so we're going to start and do a 3-minute test. So I did 2:45. 2:45. 45. Okay, that's just for me. You don't have to worry about that. In the meantime, we're going to draw the thing, okay? So the main thing about this is this thing at the end. The rest of it is just electronics. So what is going on in here? All right, let's find out. Draw yourself a big version of this. So here's our Geiger counter. Spelled just like the German word for violin, although it has nothing to do with violins. Maybe some of you play the violin. Here's what's happening. So here's the thin plastic out here. Inside here, I've got argon. I'm going to let those be little circles. They're argon atoms. And remember from last semester, right? Argon is in what family? Right, it's a noble gas, right? They don't react much, and there's a reason for that. So at the other end, there's a wire that's inside this thing. And the wire is, I better draw it like that, not complete. How are we doing on our time? We've got 1 more minute for our test. So what happens is alpha, beta, and gamma come in here. I'll draw the symbols, alpha, beta, or gamma. They come in here and they knock electrons off the atom. Bam, they hit a neon, and suddenly the neon becomes plus, and another one becomes plus. And the more pluses they are, the more I can do something you probably learned about in 8th grade, and that is complete a circuit. So then the circuit becomes electrically complete when I get enough of them going through here. And so when the circuit completes, so I'll say the more neon atoms that are turned into an ion, we say that are ionized, the more the circuit is complete. And stop. Whoop, it was at 73. So our count is 73 clicks. We'll come back to that, okay? But that's what we had in our classroom today. Okay, let's finish our Geiger counter. You know what I'm saying? So here I got like, this is a circuit, right? So I got this side's like positive, this side's negative. And then I got an incomplete circuit. This is a wire. And that wire is incomplete, but it becomes complete when these guys float in here, right? And the more positive neon atoms, so this would be like AR plus, would be that, okay? So the more positive argon, sorry, I meant argon. The more positive argon atoms, here, erase neon. It's argon, pardon me. So the more positive argon atoms there are, the more the circuit is complete and the more clicks are heard. So frankly, the more clicks, the more radiation there is. Because I got more and more of these guys that are ionized, okay? And when they're ionized by radiation coming in from the end, the little positive atoms can make this circuit complete, and then electricity can flow. And the more it flows, back here I get the clicks. Click. And that's over here. Let me lift this up again. Okay, so there's my Geiger counter. It goes back into here, and then the electronics in here make it undergo a click, and you see the number, and you hear it because there's a little amplifier here. That's a symbol for amplifier. I turned it off, but it's still kind of working. I can reset it. Just for fun, we can let it make some more clicks and make some more numbers, okay? So whatever, I'll just let that run for a while. It doesn't really matter. But when I'm done, it's really important I put this little plastic piece back on because it's so sensitive at the end, and I'll do that when I'm finished today. Okay, so let's look back. Yeah, the more argon atoms that are ionized, the more the circuit is complete, and the more clicks are heard. More radiation equals more, let's use the other word for it, more counts or clicks. However, you know what this thing does not tell you? The Geiger counter does not tell you what? The of radiation. And if you guessed it, the Geiger counter doesn't tell you what kind of radiation. That's the big thing, okay? Okay, let's see what else was I going to do with you. Okay, so units are in clicks or counts, but here's the deal. We got 72 counts in 3 minutes. Data from a Geiger counter is in counts per minute. Or here's how it's abbreviated, CTS over minute. Well, check it out. We got a problem. We did ours for 3 minutes, so we got to do a little dividing. 73 divided by 3, 73 counts divided by 3 minutes. And I think you can see that's going to come out to about 25. Let's see, 24 would be about 24 and a half counts per minute. Now, I've done this for years at the school, and that's really a typical background radiation amount, okay? So don't think I'm getting zapped at the school there with a bunch of radiation. You are all the time, too. It's naturally occurring. So there's always a natural background radiation. And that's what we call this, okay? Our background radiation today is basically, well, let's put 24.5 counts per minute. Okay, that's what it is here today. Sources? Can you guess, what are some naturally occurring sources of radiation? Where does it come from? Where does it come from? If you guessed the sun, you're right, it's a big source. But other stars too. Obviously, they're further away. The sun's pretty close. What else? The earth and soil. Sometimes there's elements in the earth that are radioactive, and they're just naturally in the soils of the earth or the rocks. And what about the school? Well, guess what? We make this stuff from the earth. I got bricks, I've got wallboard, and all of that was made from material from the earth. So construction materials also have radiation in them. They come from the earth, ultimately. Bricks, walls, cement. Now, the good news is this doesn't really hurt you. Your body has evolved through the millions of years. The people have evolved, all animals have evolved to accept radiation. It's part of what hits us all the time, okay? Animals and plants are used to this. So I'll say plants and animals evolved with natural radiation. Now, that doesn't mean we can take radiation. If I'm at a power plant, a nuclear power plant that has an accident, I'm going to get an unhealthy dose of radiation. My body can't take that, okay? But natural radiation occurs all the time, okay? All right. Finally, let me look and see if we done the other things. Right. So Geiger counter, in German Geiger Müller-Zähler, and it's in counts per minute or clicks per minute. Background naturally occurring sources. Right. Let's talk about the null effect or zero effect in English. So I'm going to erase this, maybe at the top. I really want something else to erase with. There we go. The zero effect, whoops, or in German null effect, means you've got to subtract out the background radiation to have your data make sense. For example, let's take some raw data and counts per minute. And then some actual data. All right, I got to write some stuff down because I haven't thought about this, but it'll just take me a minute. What do we have? Okay, so I have, let's see, so we have 225, 130, 73. Eight, and let's make one more. 35. Okay? All right, here we go. So let's say you do a measurement and maybe I measure the radioactivity of a piece of chalk or something. So I have this very close and I measure it for a certain amount of time. And here's my raw data. So I have 225, 130, 73, 48, 35. Okay, the problem is what? We've got a background radiation, okay? Okay, so our background, let's say that equals 24 counts per minute, just to make it easy. Oh, so really my actual data is not 225, it's what? 201, isn't it? I got to subtract 24. And my actual data here is not 130, 106, isn't it? Here it's not 73. It's 49. Here it's not 48, but 24. And here it's not 35, but it's 21, is that right? No, it's 11. Ta-da! Okay, so that's called the null effect or zero effect. You got to start with 0 by subtracting the background radiation. And that's what we did, didn't we? We subtracted 24 from each value to get the actual sort of thing. Now, yeah, I still got a little time before I have to leave, so I'm going to do something else with you as well. I want to talk about alpha, beta, and gamma and how they can be blocked. So how could I make it so the radiation, for example, doesn't go into a Geiger counter or doesn't go into you? Let's find out. Okay, so here we go. Radiation. Make a little chart with me. Alpha, beta, gamma. Make sure we know the name. Alpha, beta, gamma. What is it? Well, if you remember, alpha, this is review, right? But alpha was a helium nucleus. There's 2 protons and 2 neutrons. Beta was just an electron. And gamma is light. It's a type of light. So it's not actually a particle at all. Okay, now, turns out they differ in how much they get into your body. We're going to call that penetration. Because it can, of course, harm you. Yeah, I think it's going to stay. It can, of course, harm you if it gets into your body. But the thing about alpha is it's so big, relatively speaking, that the penetration is low. And it can be shielded with our skin. Your skin keeps out alpha particles, or even just some pieces of paper, okay? Beta is smaller. It can penetrate easier, so it can get more into you in that respect. So I'm going to call it a medium amount of penetration. You can keep it out, but it has to be something bigger. I've got aluminum here. So an example would be a sheet of aluminum. We'll keep it out. I think you all know the symbol Al is aluminum. And then we got gamma as a type of light, but it's a wavelength, as they say, which is really small. It can go between atoms and go right through you. So its penetration is very high. Again, there's good and bad uses of gamma radiation, but it can go right through you, and it can potentially harm you or help you, depending on how you use it. To block it, I need something like this. You ready? This thing is a piece of lead, and it's heavy as lead because it is lead, okay? I got it wrapped in plastic because it's not good to touch lead. You don't want to get it on your skin. You get lead poisoning. You don't want to breathe it either. I'm going to put that back. But we're going to refer to lead again when we talk about nuclear power plants. If I'm where the reaction's happening, I don't want to be there. I want to be outside where the reactions happen and outside a big amount of lead. Now, you know this too. You've been to the dentist probably or gotten an x-ray, and guess what? Lead can also block x-rays. You ever have to put on a big robe of lead? And they do that to keep the x-rays out of the rest of your body. So they may just do your mouth for a dental x-ray, but they want the rest of it to be screened or shielded. They want you to be shielded, so you wear a lead apron to keep x-rays out. They're not using gamma rays, they're using x-rays, by the way. Okay, so to stop gamma, I need like thick lead. L-E-A-D is lead. Blei in German, right? Super. Okay, and that, my friends, is what I wanted to have you take notes on today. I had to do this at school, and I couldn't do it this morning, so I couldn't do a live stream. So I'm going to just save this and say goodbye and have you watch it and take some notes. So fare thee well. We'll see you soon for real. Bye.